Does Pretesting Matter? By Josh Lucas. One question that's coming up at our school is, does pretesting matter? If I give a pretest at the beginning of the unit, differentiate from the data I receive from that pretest, and then give a post-test at the end, will that post-test be different from a teacher that just does a regular lesson, differentiates on the fly, and then gives a post-test score there? What is beneficial to the students? If we truly put students first, then we must find a way to continuously improve testing administrations and techniques. And therefore, if the pretesting policy shows a significant difference, how can we make it helpful to all students, not just those students that, quote, are testing out? That means that they do real well on the test and they're given another project, or they're able to be the, quote, helper. How can we help all students? Why don't more teachers use the pretesting at the beginning of their lesson? One comment I've read and talked to my colleagues about is the complaint that, hey, most students don't test out. So I'm wasting my time, their time. I'm giving them additional anxiety. Not only do they have to do the post-test, they have to do a pre-test, they have to do the curriculum-based assessments that the district makes, which are 9-week tests, the CBAs, plus tax test. Now, some of the good things that could come about pre-testing is that it provides a preview of the course content. So if we force a student to sit there on the pre-test, even if they're not going to get it right, they still look and they're able to see, hey, this is what I need to be looking for because it will be on the post-test later. So it gives them a glimpse of what's ahead. Also, it's a real valuable tool for teachers to create small group partners. If I know that certain students are getting 90 to 100, they're doing a certain activity, 30 to 50, maybe they're in my small group after school or during class. Does the current testing policy at the end of the unit fit all students? A similar study to the one that I'm going to discuss was conducted in courses of physics and English of 9th graders in Turkey in 2009. According to the study, the effect of quizzes at the beginning of a unit on learning was significant. There was a significant difference. The control group in this experiment was just given the regular lesson. The teacher differentiated, during the week, and then they were given a post-test score. The experimental group was given a pre-test, differentiated from that data, and given a post-test. And so the post-test scores on the experimental group were higher than the control group. Now, there's possible solutions to the pretest policy. Either teachers can give the pretest or don't give it. Now, if they do give a pretest policy, maybe they could give it to all the students, or they could give it just to the students they think that will pass, the ones that just want to participate. The pretest could be really advanced so that you expect everyone to get 100% in order to, quote, test out, or maybe just slightly above average, so 90, 95. And once a student tests out, the teacher can either give them an advanced project to work on that still covers the objectives in that concept during the week, or maybe they could just be an advisor to students as the teacher instructs. They could break into small groups, and then those people that tested out could help there. All students can take the post-test, or maybe you could substitute the pre-test scores if the students tested out of them. Now, in this study, there were specific rules that were followed. In the control group, no students were given pre-tests. It wasn't even discussed. In the experimental group, they were given a pre-test. They were expected to complete them. All the students were, up to the best of their ability. That way, they were forced to look at it and examine it. Earning 100% is considered testing out. Once they are tested out, they are given a project to work on instead of their daily work as the other students were receiving. All the students will take a post-test at the end, and they will not substitute their pre-test score for that post-test score. Now, in the control group, there was 3 6th grade math teachers, each teaching 3 classes. There's about 25, 28 kids in each class, and that was similar to the experimental group. Also, what's similar between those two is that they were both expected to follow the district-specific objectives, the DSOs that were created by Keller ISD, and that would make them every week be on the same concepts. And you know, all the participants, all the teachers, all the students are on the same campus. And the study was conducted at the beginning of the 2010-2011 school year at a 5th and 6th grade campus over a 7-month period. Now, those tests that were collected for data are on the right-hand side here, and just to explain to you what the curriculum-based assessment, the CBA, covers. CBA 1 is a 9-week review over the previous 9-week concepts that were taught. And included in those concepts were the multiplication, division, and order of operations, as in test number 1. The tests and the CBAs were collected all the way up to March. In each test, each CBA was the same for each teacher in the control group, each student in the control group, each teacher in the experimental group, and each student in the experimental group. Now, the original question of the study is whether pretesting students will lead to a higher post-test score. One complaint I got is that currently in the pretest classes that started the pretesting, which was an experimental group, there was a large amount of GT students. And you could see this number here, that the number 1 is the group, the experimental group that do the pretesting. 2 is the ones that do not. So you could see there's a much larger number of GT students in the experimental group. So the similarities between those numbers of students are not, well, they're not similar, and so it's the variance is not assumed here. And so we can even look at, just thinking ahead on the means really flip-flop here. Okay, so even right here, the experimental group is higher, the control group here is higher, but the numbers are not the same, so we really can't see or can't discuss if there is a significant difference here. Also, we're kind of, with the GT students, we're working with the ceiling effect, that their grades are already so high that they can't get too much higher. They could drop significantly, which would tell me that the pretest did the opposite effect on it, but they could not improve. So I wanted to run the GT, this is an independent t-test, just to show some of these numbers. And I also did all the students not GT. All right, and so what it showed here is it showed that in CBA 2 customary measurements, and CBA 3, in all 3 of these there was a significant difference. The significant difference found in CBA 2 was less than 0.001, and the difference between the two means here was 10.1515. Now also there is a significant difference between the metric and customary unit test, and that is less than 0.002. And the difference between these two numbers of the mean is 3.6591. And also there's a significant difference between the CBA score of less than 0.001, and the difference here is 3.2039. Now, just like there was a complaint of too many GT students in the pretesting group, the experimental group, there was a complaint, or teachers noticed that in the control group there was a large amount of other students in their group. So what I did is I did an independent t-test removing GT students, 504, special education, and ESL students. Now this was the same as the previous test. Really, there's slight difference. CBA 2, metric customary, and CBA 3, there was all significant difference here. In CBA 2, there was a significant difference of less than 0.001. The difference between these two means was 9.0515. Also, there's a significant difference here of less than 0.003, and that difference of this mean here is 3.408. And finally, there's a significant difference here of 0.003, and the difference here in the mean is 2.8355. So whether you took out the special education, the ESL, it was still similar to all the other students combined, not including GT. So the data analyzed in this study shows that there's a significant difference between the students who received the pretest and those who did not in the final 3 test administrations, or that were administered. And I believe that it's because they just got better. They got better towards the end. The students got used to it. Pretesting is valuable to students even if they don't, quote, test out. They're able to see what is covered in the topic. Teachers can see what their students already know, and those who test out will still be challenged with a substitute assignment. The study shows that an experimental group progressed in their pretesting policy understanding and implementation, and a significant difference occurred. In conclusion, here are some additional pretest policy topics that can be conducted. We could do a long-term study that includes 6th grade math Texas or tax test scores in the study. We can use surveys to triangulate our information. We could continue to make the pretest a challenge but lessen the difficulty so that more students can test out, thus producing a smaller group of other students that we can improve their knowledge by teaching them. We could locate new teachers on other campuses that have similar amounts of GT to compare our experimental group to, and expand the study to reading and science. Well, it's been my privilege presenting this to you, and I hope that you've learned a little more about pretesting policy and those possibilities.